right, so our goal today is to try to shore up our learning from yesterday, and so I want you to replace this with S of t is equal to t to the third minus 12t squared plus 36 plus 36t plus 3. And I really think from what I saw yesterday, again, yesterday you guys were kind of the guinea pigs. That's how it was the first 2 years I taught calculus. Every day they were kind of guinea pigs. You just didn't know for sure how the lesson was going to go. But now I know and I can see where we need to be. So, A for the day. How do I find velocity? Yep, the velocity is equal to the derivative of the position function, which is? Excellent. How do I find acceleration? Which is, yep, 6t minus 24. Are there any questions at this point? I think it is by far best practice to draw a graph of those two so you can answer the following question. Anybody, how you want to draw a graph of that? Parabola, right side up, good. What are you looking for? Where it crosses the x-axis. And so I'll try to find it by factoring. How's that? Is that factor? What if it didn't? What would you use? So the cube? Use the quadratic formula, right? If it doesn't factor, use the quadratic formula. Whoop. Not minus 8, but minus 6. So tell me how to sketch a graph then. 2 and 6. Doesn't have to be a super pretty graph, just something to kind of, get a general idea. Y'all good? So let's answer question C, and then we're going to have a couple more challenging questions. When is velocity positive? Yep, so velocity positive, we're going to go 0 to 2 or negative infinity to 2, union 6 to infinity. We all good there? So we've learned a lot.
Why is it infinity to 2?
You could put it negative infinity to 2, that'll be fine. I didn't put a negative infinity only because t refers to time, right? And we're not going to talk about negative time. Okay? What's that? If you did, I'm not going to mark it wrong. I'm not looking for ways to take points off. Okay, all right. So, here we go. I'm trying to check your understanding, okay? Right here, is the velocity positive or negative? So which direction am I traveling? To the right. So the particle starts traveling to that direction, right? What happens here? It changes and it starts to go to the left. And here is the velocity positive or negative? Still negative because it's sitting. Can we hear them?
Yeah.
Let's go. All right, here we go. All right, so I'm pointing here. Velocity positive or negative? Good, so I'm traveling to the velocity positive or negative? So I'm traveling to the acceleration, positive or negative? Negative, why? Because the acceleration is the derivative, right? So you can see that the acceleration is negative there. Here, acceleration positive or negative? Positive, because the derivative is positive, see? See how I can kind of look at this and anticipate the acceleration graph as well? Let's do that. When is the acceleration positive? Look at this. What shape does that make? Makes a line. And usually when you think about lines, you think about where it crosses the y-axis. We don't really care about where it crosses the y-axis, do we? We care about where it crosses the x-axis. Anybody look at that and see where it crosses the x-axis? Positive 4? If you set a function equal to 0, that will tell you where it crosses the x-axis, right? So that's going to happen at positive 4. Does the line go up or go down? Goes up. There we have it. That was pretty bad. There we go. So the question is, whoop, that was really bad. Come on, Gens. I ate a bowl of stupid for lunch. Here we go. So, when is the acceleration positive? 4 to infinity. We all good? All right. So, for this next question, it says, when is the particle speeding up? What I'm going to do is I'm going to make a little chart of velocity and acceleration. And I'm going to mark 0 because that's when it starts. Can somebody think of other points that I want to put on my chart? 2, 4, and 6, because those are all the times which the acceleration or the velocity change. So let's fill out this chart. From 0 to 2, is the velocity positive or negative? Positive. From 2 to 4, is the velocity positive or negative? 4 to 6? And 6 to infinity? Morgan? 0 to 2, I said it's positive because it's above. 2 to 4 and 4 to 6, you can see that it's below. And then 6, positive again.
Okay.
Good? I just saw you were writing stuff down. Just, I know you weren't here yesterday, so
Yeah.
yep, trying to help you out. Trying to be a helpful
Got
person. Helpful teacher. Okay. How about acceleration? Negative? Negative? Can somebody describe to Morgan how we know when a particle is speeding up as opposed to slowing down? Same sign. So when acceleration and velocity are same signs, we say it's speeding up. This just means it's speeding up in the direction to the left. This means it's speeding up in the direction to the right. That's what that means contextually. So when is a particle speeding up? From 2 to 4 and from 6 to infinity. So it's slowing down when it's opposite sign. That'll be 0 to 2, union, 4 to 6. So you guys realize, like prior to yesterday, that's a pretty complicated question, right? Right now, not too bad, right? So once again, if you just think about how many things you've learned from the beginning of the year, it is ridiculous. So every day you're learning new things and you're putting in practice. But this piece we'll be reviewing throughout the year, and this is the #1 type of question you get on the AP exam, okay? And you'll be great at it. All right, last question. What is the distance the particle has traveled over the course of? We're going to do 8 seconds in this situation. The previous problem that I don't want to do, we're going to get rid of that. So, what 2 functions do I have to consider that are going to tell me how far it's traveled? Velocity and position. Because distance is going to be determined by its position. So I have to consider the start, which is time equals 0. I also need to consider where it changes direction, right? At what time did it change direction? That's when the velocity changes from positive to negative or negative to positive. 2 and 6. Yep. I just wanted you to say it louder. Just want to hear Veda's voice. We love Veda's voice. I love Veda's voice. Will you sing for us? Monday, Veda's going to sing and Lindsay's going to rap. Yeah! Let's go! So I got, it changes direction, time equals 2 and time equals 6. And then I got to consider when the object ends. When it doesn't move anymore, that would be at time equals 8. Okay. So, what up, King Kong? All right, so let's figure this out then, okay? Oh, you're fine. Can somebody tell me, what do I do with these values? Plug them in the function, right? Now, here's where I like to use my graphing calculator to my advantage. I like to take this and plug in the function. And this is the easiest way to go about this. I go x to the third minus 12x squared. Whoop. Watch in case I make a mistake so you can tell me. Plus 36x plus 3. So I've got the function in, and I'm just going to go to the table. And that way I can just type in 0, 2, 6, 8. See that? How that made it easier to just type everything in? That's going to save you time as well in the AP exam. To tell you the truth, a lot of times people need more time. They just don't know what they're doing. They can't sleep through part of it. But here we go. So what's its position at time 0? 3, and then 35, and then 3, and then 35. So it looks like the object actually starts at what position? Starts at 3, and then you told me by looking at the velocity graph, does it start by going to the right or the left? Yeah, you can tell it goes to the right, and then to the left, and then to the right. That's what you can tell by the graph. So sure enough, it goes over to 35, it goes back to 3, and then it comes back to 35. So just to be clear, the displacement of the object is 32 units. But it's traveled further than that, right? It traveled 32 plus 32 plus 32, which is 96. Good? Okay, we need to adjust your homework questions, okay? Go ahead and take out your homework.
Wait, do we need a unit on that?
No.
Okay.
Half the time on the AP exam, they will give you a unit. Half the time, they won't.
And about on the Gantz exam?
No, don't worry about it. Carter, you're a funny guy. Make me laugh. Okay, you already did the first one, right? The second one, I want you to do that fourth. Yep. I would encourage you to do that one last. Okay? All right? And then this one was a calculator one. We're going to switch that to the following. S of t is equal to negative t squared plus 10t minus 12. So that would be your second problem. That's the one I encourage you to do next.
Okay, yeah, it was just the T.
And it says over the course of 4 seconds, you're going to go 8. Nope, the second one can stay as 5. And then we have one more adjustment. This guy, we're not going to do that function. We're going to do S of t is equal to t cubed minus 9t squared plus 15t plus 10. So I would do that third. That would be your, and over the course of 4 seconds, again, we're going 8 on that one. So I drew up answer keys for the second and the third problem already, and I have the fourth one will be posted. I'm going to post those right up in front of class. I'm going to post a video for Miss Morgan. You guys have 20 minutes approximately. I would highly encourage you to get at least problem number 2, which I just wrote up, or problem number 3, which I just wrote up. Try to have that done before the end of the hour. You want to solidify this in your learning. Right now, we are scheduling to test next week, Thursday. Last question. Raise your hand if you are in the musical. 1, 2, 3. Okay. So I know you guys are going Wednesday. If that affects your ability to take tests on Thursday, let's try to talk before Thursday comes. Okay? All right. Time is yours. Go. You're gone all